Namaste, dear students. Today we can start with the new concept. Before going to this new concept, you know that because of Corona, your second PUC syllabus has been revised and metallurgy topic it has been removed from your syllabus. So, from today's class, I will start with the another interesting topic or another interesting unit of inorganic chemistry, that is coordination compounds. Here, before going to the definition of coordination compounds, I want to give some important applicability of this coordination compounds or coordination complexes. You know that there is a existence of life on this earth. Even we means animals and plant kingdom. Everything it is existing on this earth by using some chemical compounds. Those chemical compounds are responsible for the existence of life on this earth. You know that oxygen it is responsible for the respiration of animals, as well as we know that we are getting the food from the plant sources, and all these processes are taking place by the use of some chemical compounds. For example, we can start with the oxygen. Here, production of oxygen it is taking place in the photosynthesis process, which is taking place in the plants. In photosynthesis process, there is a formation of food, or there is a formation of carbohydrates along with the liberation of oxygen gas. Here, to get the oxygen from the plants, we need the that plant should go through the photosynthesis process, and in this process plants are using the one chemical compound. That chemical compound is called as the chlorophyll. It is the reason why plant leaves are green in color. That chlorophyll it is nothing but a chemical compound or a coordination compound or a complex of the magnesium metal. Because of this coordination compound, that is coordination compound of the magnesium, we are going to get the oxygen on this earth. This is the one reason. And second one is, in our body there is a blood, and blood is responsible for the transfer of or transportation of the oxygen to the every cell of our body. And you know that blood is red in color. Why it is red? It is because of hemoglobin. And this hemoglobin it is nothing but the a coordination compound or a complex of iron. Okay, and this coordination compound or this hemoglobin it is going to transport the oxygen in our body, that is, and it transports oxygen to the every cell of our body. This is the second reason. And third one is vitamin B12. This vitamin B12 it is one of the vitamin, and it is essential to our body. And if there is a deficiency of this vitamin B12, we will suffer with the pernicious anemia. And this vitamin B12, it is also a coordination compound or a complex of cobalt. Okay, to exist the life on earth, three important coordination compounds are there. One is the chlorophyll. It is responsible for the oxygen, hemoglobin, and this is responsible for the transport of oxygen to the every cell of our body. And next one, vitamin B12. It is the coordination compound which keeps us healthy. So here this is the importance of coordination compounds or the complexes in the biological systems. Along with this one, we are using the coordination compounds in many fields. In medicinal fields, we are using coordination compounds. In the polymers, we are using coordination compounds. In many metallurgical processes, we are using coordination compounds. And in textile dyeing, we are using the coordination compounds. So here, coordination compounds, these are the important compounds of the inorganic chemistry and which are having the wide applications in our day-to-day life. So it is very important to know about the coordination compounds, and now we can start with the coordination compounds, that is definition of coordination compounds. Here D block elements, you know that D block elements, okay, are transition metals, we can call those here transition metals. Those are having a special property to form the coordination compounds or the complexes. Okay, here transition metals, these are going to bond with the many neutral or negative molecules, and it is going to form a type of chemical compound. That chemical compound itself is called as the coordination compound or the complexes. Here we will study about the definition of coordination compounds as well as the terms which are used in the coordination compounds in the next classes. And before going to that, we have to go with the some type of the chemical compounds which are formed by the mixing of the two salt solutions or two solutions in the stoichiometric proportions. That is called as the molecular compounds or the addition compounds. Here molecular compounds are addition compounds. These can be defined as, these are the compounds formed when solutions of the two salts or two salt solutions are mixed in equal proportions or in stoichiometric ratio to form a crystals or to form a new type of the compounds. Those compounds are called as the molecular compounds or addition compounds. Here we are having an example of that one. Potassium chloride, it is one of the salt solution. Magnesium chloride, it is another type of salt solution. When you mix these two salt solutions in the stoichiometric proportions, you will get the new compound. And this new compound itself is called as the kernelite. Its name is the kernelite. And this kernelite, it is a compound of, or it is a mixture of two salt solutions. One is potassium chloride and another one is the magnesium chloride. In the same way, we can also get another type of compounds or products by the mixing of two salt solutions. For example, iron cyanides, FeCN twice, plus potassium cyanides. These two are the solutions. When you mix these two solutions in stoichiometric proportions, again you will get a product, and this product can be written in another form, that is K4FeCN6, potassium ferrocyanides, and this is another type of the compound formed by the mixing of these two solutions. So in molecular compounds or addition compounds, again we are having two types. One is double salts and another one is coordination compounds or the coordination complexes. Oh, you have got, that is in molecular compounds or in addition compounds we are having the two types of the compounds. One is the double salts and another one is the coordination compounds or the complexes. In addition compounds, first one is the double salts. When you mix two salt solutions in a stoichiometric proportion and let them to evaporate, you will left with the some type of the crystals or compounds, and those compounds are called as the double salts. In double salts, we are going to get the compounds, for example, kernelite, and next one is the Morse salt and potash alum. These type of compounds are considered as the double salts, and these compounds behave in the same manner as the parent solutions behave. For example, Morse salt, it can behave as the, or it is having the properties same as the parent solutions, that is ferrous sulfate or the ammonium sulfate. Even this kernelite also have the same properties which are shown by the parent solutions, that is potassium chloride and the magnesium chloride. Here double salts which are having their identity or which are stable only at its solid state or in the crystal state. When you mix those crystals or when you mix those solids into the proper solvents or into the water, these double salts are going to lose its double salt character and it is dissociated completely into its ions. For example, if you mix kernelite in the proper solvent, this kernelite is dissociated into its ions as K plus, Cl minus, then Mg2 plus. And if you test for K plus or Cl minus or Mg2 plus, you will get the positive test for these ions. For example, if you test with the silver nitrate solution, you will get the positive test for the fluoride ion. So these are considered as the double salts. Here double salts are the addition compounds or molecular compounds. These can stable at its solid state or crystal state, or these can show their identity only in the solid state but not in the solution or aqueous state. This is called as the double salts. Okay, now we can move towards the another type of molecular compounds, that is the coordination compounds or complexes. Here we are having coordination compounds. In the beginning itself I have told coordination compounds, these are the compounds in which transition metals or any other metals which are bound by the negative ions or the neutral molecules to form some type of the cluster, and that itself is called as the coordination compounds or complexes. For example, we are having potassium ferrocyanide. Okay, in this one, when you mix these two solutions and let it to evaporate, finally you will get the crystals or a chemical compound, and that compound itself a coordination compound or a complex, and its name is potassium ferrocyanide. Here special property of coordination compounds is, in the case of double salts were existed only in their solid state, and when you dissolve in a proper solvent, those double salts were dissociated into their ions. But in the case of coordination compounds, when you mix this potassium ferrocyanide in a proper solvent, this potassium ferrocyanide, it is going into partial dissociation. You will not get the complete dissociation. It is going into the partial dissociation, and you will get K plus ions. Along with the K plus ions, you will get the ion of this complex, that is FeCN6, that is 2 minus. Sorry, FeCN6 4 minus. Okay, here this whole complex is considered as the another ion in this solution. And here coordination compounds are the compounds which retain its identity in the solid state as well as in its solution states. In both these states, these coordination compounds retain their identities, and that itself, these complexes or these coordination compounds will give the positive test for the some ions, but not for the some ions which are present in this square bracket or which are present in this complex. Okay, main difference between double salts and coordination compounds is double salts which retain its identity only in the solid state but not in the solution state. But here coordination compounds, these can retain its identity in the solid state as well as in its solution states. Okay, and if you dissolve this solution, this substance in the proper solvents, you will get the positive test for K plus ions but not for the Fe2 plus ions as well as the Cn minus ions, because these ions are restricted and these ions are present in the square brackets, and this whole molecule or this whole ion will exist in the solution but not in the free Fe2 plus ions or Cn minus ions. Okay, so this is the difference between the double salts and the coordination compounds. Okay, students, this is the basic thing we should know about the double salts as well as the coordination compounds. And here coordination compounds, it is an interesting topic. Even coordination compounds also colorful substances. Okay, we can study about terms which are used in the coordination compounds as well as the different theories which were contributed to the explanation of structure as well as the formation of the coordination compounds in our next class. Thank you.